Today we're going to combine everything you know about surface area and volume to determine the surface area and volume of composite solids. Similar to determining the area of composite figures, composite surface area and volume require that you look at the entire solid to see what shapes it is made of, and then determine an individual measures that you combine later. So the first thing you always want to do is observe what shapes do you see. Then plan the most efficient way of determining the surface area. Determine each shaped surface. Make sure not to include faces that are touching or inside the solid. 4. Combine the values of each surface area. And 5. Complete with appropriate units. Surface area is in units squared. Finally, you want to evaluate for reasonableness. So the first thing I notice is that I have what looks like a house. It could be considered a pentagonal prism if I look at the two shapes together. And I may want to actually work on it as a shape that has a rectangular prism and a triangular prism. So in order to facilitate what we're doing, let's do this on another page. So I notice I have two shapes. Both of them are prisms. So I know that I'm going to be working with the surface area equals 2 base areas plus perimeter times height. Surface area is 2 base areas plus perimeter times height. So let's look at one shape at a time. Let's start with the rectangular prism. I'll outline that here in green. Notice that the triangular prism is sitting on top of the rectangular prism. And the face inside, that I'm going to color yellow, is part of both prisms. It's a rectangle, part of the prism side of each, so we don't want to include that part. On one of mine, on the rectangular prism, I could consider that one of the base shapes. On the triangular prism, it's a face, and it's definitely not the base because it's not a triangle. So what I want to do is work with these separately. Instead of doing 2 base shapes, I'm just going to do 1 base shape plus the perimeter times the height. I'm going to exclude the yellow part as the base. Let's work with that. If I use the base shape as the yellow shaded part, I have to use 21 by 11 as the measurements of my base. I have my measurements for height, perimeter, and base area. So the surface area of the rectangular prism minus the yellow face, which is inside the shape, is 615 yards squared. Now let's look at the triangular prism. I need the 2 base shapes, and I need 2 of the 3 sides. I don't really want to do perimeter times height unless I want to subtract the side that has the 11 by 21, which I can do. But either way, I do need 2 base shapes. And I can include the perimeter times the height and then subtract the 1 base. So the perimeter is 50 and the height is 11. Note that the heights of the 2 shapes are different because on the rectangular prism we use 21 by 11 as the base shape and 6 as the height, whereas on the triangular prism we have to use 11 as it's the difference between the 2 base shapes. So now we're going to put this together, and at the end we're going to have to take away that one piece that's inside the shape, that 21 by 11. Now that we have the surface area of the triangular prism and the surface area of the rectangular prism, we can add them together. And we get 1,144 yards squared. Let's look at the second example. What you notice is that we have a cone on top of rectangular prism. Again, we want to see it as a hollow space because we're only doing the surface area. We do not need the base of the cone or the circle, and we also don't need that seam circular area that's part of the rectangular prism. So first, let's make sure we know the formulas for the surface area of a cone and the surface area of a rectangular prism. The surface area of the cone is usually 1 base area plus 1/2 of the circumference times the slant height. Then the surface area of a prism is 2 base shapes plus perimeter times height. Let's work with the surface area of the cone first. There is some missing information and we're going to have to figure that out. So if I have a cone and I know that I don't need the base area, I can exclude that from my cone. I do need the circumference and I do need the slant height. So the circumference of my circle is 4 pi. What I've been given is the height of my cone, not the slant height of my cone. I'm going to need to use the Pythagorean theorem in order to find the slant height of my cone. So if you consider the cone a right triangle, it said that this height was 5 inches. And it stated that the distance across here was 4, which is the diameter, which means this part of the triangle is 2. So we need 2 squared plus 5 squared equals my slant height squared. And the approximate square root of 29 is 5.4. We're going to go ahead and use our calculator to determine that, and always round to the 10th place. So for the surface area of the cone minus the base, because that's inside the shape and it's not on the surface, I have the surface area equals 1/2 of the circumference times the slant height, or 2 pi times 5.4, or approximately 10.8 pi inches squared. Now we have to use the rectangular prism. For the rectangular prism, we do have a surface area formula of 2 base areas plus the perimeter times the height. But we are going to need to subtract the area of the circle, because we do not need the area that's underneath this part on that rectangular prism. So we need the base area, we need the perimeter of the base, we need the height of the solid, and we're going to need the radius of the circle. To determine the height of the solid, I'm going to use the base area as 7 times 4 and the height as 2. Since I already have the surface area of the cone in units with pi, I'm not going to change pi here, but I do need to combine the two values. So I have the surface area of the rectangular prism, and I'm going to add the surface area of the cone. Together, that would be 100 plus 6.8 pi inches squared. Let's look at another object that uses the idea of circle. So now we have a cylinder with a hemisphere on top of it. Our surface area for a cylinder would be 2b plus ch, and the surface area of a sphere is 4 pi radius squared. For the surface area of a sphere, you never worry about the internal part. It doesn't have a base shape. For the surface area of the cylinder, we only need one of the bases because this base, the top of the cylinder, is no longer part of the surface. So instead, we just have one base shape plus circumference times height, but we still need to do the surface area of the sphere. However, we only have a hemisphere, so we have 1/2 or pi r squared. The variables we need to determine are the base area, the circumference, the height, and we need the radius. So the total surface area is 57 pi yards squared. For volume, we need to do something similar, but instead of worrying about each surface, we just have to add the two volumes together. We need to determine what shapes we see, the most efficient way of determining the volume, finding each shape's volume, and combining the values. Now in this case, because we have a rectangular prism with a triangular prism sitting on the top, and we're trying to fill up the whole thing, we might want to talk about using the perimeter and base shape, where the base shape is a combined area. So if you consider this to be the area of the base shape, We just need to find the area of the triangle and add it to the area of the rectangle. Then we can find the volume of the entire pentagonal prism. Don't forget, the height of the prism is the distance between the two base shapes. And since the base shape is that pentagon, the other pentagon is behind it, and the distance between the two pentagons is 11. And units for volume are always in units cubed. Similarly, we can find the volume of the rectangular prism and the volume of the cone and add those together. So we have 56 and 20/3 pi inches cubed. You cannot add the 56 to the 20/3 because 20/3 is multiplied to pi. For the volume here, I have the volume of a half of a sphere and the volume of a cylinder. The volume of the cylinder is base times height. The volume of the sphere, so the variables that we need are radius and base area and height. So the volume of this combined shape is 57 pi yards cubed. Thanks so much for watching, and congrats on finishing Chapter 9.